So we are reviewing for our Chapter 2 test. Our first question is asking us to identify the domain and range based on two different types of descriptions. In the first one, we're given just some ordered pairs, and the second one, we're given a picture. Okay? For the first one, domain will be our x values. So what are the x coordinates? Okay, and you can write them in that order. This is the order you see them. You can put them in from smallest to largest. It doesn't matter. What would the range be? Okay, those are your y values, 3, 5. Do we have to write the second 3 again? No. All right, and then the 6. Okay, so again, domain are x's, range are y's. The question also asks for us to determine if it's a function or not. Would this one be a function? So if we plotted the points, none of them would line up vertically, correct? We have all different x's. What you're looking for in terms of it not being a function would be the same x being paired with different y values. Okay? So this is a function. All right, question 2. This time we are given what shape? A parabola. Now, there are some points plotted to get the actual parabola, but when they talk about the domain and range for this graph, they're looking at all the points on the parabola, not just the few that they've indicated. Does that make sense? Okay, so if we think of parabolas continuing forever, and we expanded this graph, our parabola would continue going out this way, correct? So as we think in our x direction, can we continue moving out for x's? Are there any x's that we can't use? All right, so we would say that our domain would be all real numbers. And in that interval notation, what do we mean when we say all real numbers? We're going from negative infinity up to positive infinity. Okay, we want all of it. Yes? Okay. For the range, do our y values continue in both directions forever? No. Where's the cutoff? Up at 3? All right, this is our maximum point for that parabola. That's the highest our y values will ever get. So how do we indicate that we want everything from 3 and on down? What's way down here at the end? Negative infinity. We always start with the smallest and go up to the biggest. So we're going to start and say we can start at negative infinity and we can go up until we hit 3. Can we actually be at 3? So what kind of bracket do we use? The squared off ones. Okay? Question 3 says, which point could not be part of a function that includes the given points? If it's a function, remember we can't have any 2 points lining up vertically. I should go back up here. This one was a function, correct? Passes a vertical line test? All right. I'm going to give you a minute. Look through the points. Which of those points cannot be included for it to still be a function? So which point cannot be included for this to still be a function? B. Why? Okay. We have an x of 3 here being paired with negative 2. We already have 3 being paired with something else. Okay. Our second learning target is to evaluate functions. So we are given 2 different functions. The first one says f of x equals x squared plus 5x minus 6. And then we're given g of x is the absolute value of x minus 4 plus 7. It's asking me to find f of negative 3. What does that mean? Put negative 3 in for x into function f. Yes? So function f says something squared plus 5 times something minus 6. And they're asking us to dump in a negative 3. The parentheses I put in there are important because we are taking negative 3 and squaring it, which gives us 9. 5 times negative 3 would be negative 15, and then we're subtracting 6. What's 9 minus 15 minus 6? Negative 12. Okay, so f of negative 3 is negative 12. I could write that as an ordered pair. What this is telling me is when x was negative 3, my y value was negative 12. Okay, I'm fine with you leaving it like this. It just said evaluate it, but I want you to understand what it is you're finding. Right? You're finding the y coordinate that goes with that x value. All right, this one says find g of 1. This time we need to use the function labeled g. So we have absolute value. We're going to dump a 1 in for x. 1 minus 4 is negative 3. The absolute value of negative 3. 3 plus 7. So g of 1 equals 10. Okay? All right. Our next learning objective, we're switching to looking at linear equations and finding their slopes. So, given 2 points, what's the formula we have for slope? Okay? Good. y2 minus y1 over x2 minus x1. All right, let's plug our numbers in. So our y values are the 2 there and the 8. So if we do 2 minus 8, we have to subtract the x's in the same direction. So 5 minus 2. Okay? So 2 minus 8, and then 5 minus 2 goes on the bottom. That gives us negative 6 divided by 3. So our slope is negative 2. Okay? All right, I'm going to pause the recording. I want you guys to do the next two. Checking question 7. You should have 3 minus 3 in the numerator, negative 1 minus 2 for denominator. Doesn't really matter what's in the denominator because the numerator is 0. 0 divided by, in this case, negative 3. Our slope is 0. Okay. For this one, we have 7 minus 4 divided by 3 minus 3. Can we divide by 0? So this is considered undefined. Okay. We are going to start looking at writing equations for lines in our different forms. It is important that you know the name of each form because on your test it will say things like write this in slope-intercept form, write this in standard form, write this in point-slope form. You have to know which one's which. Okay? And just because it tells you to write it in one form doesn't mean you have to start with that form. It just means you want to put your final answer in that form. Okay? So, what is slope-intercept? What does that look like? Okay, y equals mx plus b. Point slope. What does that one look like? Okay, y minus y1 equals m x minus x1. Okay, and then standard. Good. Okay, and remember with standard form, we typically like what kind of numbers for our coefficients? Integers. So no fractions, no decimals left in them, right? Integer coefficients. All right. So our first question says to rewrite this in standard form. I do see a fraction. How do we get rid of that 1/4? Okay, so we're going to times everything by a 4, which gets us 8y minus 12 equaling 1x. Okay, now standard form says your x and y's have to be on the same side. So easiest thing will just be to subtract the 8y to the other side. Okay, that would be considered in standard form. Question 10 and 11. It says write an equation for the line with the given information in the indicated form. So this one we are given a slope of 1/2 and we're told that it should go through the point 4, -1. If we are given slope and a point, then we should use point slope form. We don't want to leave it in that form. We want to simplify it down to standard, but that's how we're going to start. Okay? So y minus y1 equals m times x minus x1. All right? Our slope is 1/2. We put that in for m. Our x-coordinate of our point is 4, so x minus 4. And our y-coordinate is -1, so y minus -1. Simplifying, we have y plus 1. Distributing, we've got 1/2 x minus 2. Okay. We can combine like terms, so we get this 1 to the other side. Subtract it over. Now, we do have a fraction again, and we want this in standard form. Right now it's in what form? Slope-intercept. Okay, so we started with point slope, we converted it into slope-intercept, now we have to convert it to standard. What are we going to multiply by to get rid of the 1/2? All right. If we multiply everything by 2, we now have 2y equals 1x minus 6. All right, what do we want to do to put that in standard form? So one option would be to subtract the x to the left side. All right, so -x plus 2y equals -6. That would be perfectly fine. Another option would be to subtract the 2y over to the right side and then add the 6 back to the left. Okay, either one would be fine. All right, I'm going to pause this one and have you guys try number 11. First step, you should have calculated slope. So 5 minus 3 for the top part, 3 minus -1 for the denominator. We've got 2 divided by 4, or 1/2. Yes? You can use either point to plug in. Yes? When we simplify it down to that slope-intercept form, it won't matter what point we started with. It should still end up the same. Some people don't like to use the negatives, so they would have picked the 3 and 5. Some people like to just use the first one they see. How many used -1, 3? How many used 3, 5? About the same. Okay, we'll just go with the first one. So we have y minus our y-coordinate of 3 equals 1/2 times x minus the x-coordinate, which is -1. This subtracting a negative is the same as adding, right? Distributing the 1/2, we've got 1/2 x plus 1/2 times 1, 1/2. Now we have to add the 3 over. So we have y equals 1/2 x, and I saw several people with different answers for this. We are taking 3 and adding a half to it, yes? So I saw 3.5. Is that okay? It's equivalent. Would it be the answer I put down in my equation? Probably not. Because if I'm writing the slope as a fraction, then I should write my y-intercept as a fraction. All right? If you want all decimals in your equation, then instead of writing 1/2 x, you'd put 0.5x. Does that make sense? So try to be consistent in how you put your answers down. So 3.5 is the same as 7/2. It's equivalent version. That's what I would put down here. Okay? All right. Our next couple questions deal with the ideas of parallel and perpendicular lines. What do we remember about parallel lines? They have the same slope, but different y-intercepts. Perpendicular lines? Opposite and reciprocal. So opposite sign, one's positive, one's negative. The number parts of it are reciprocals of each other. So our first one here says, write an equation for a line. It does say leave our answer in point-slope form. Okay. We want a line that is parallel to y equals 2x plus 1, and it goes through the point negative 2, 3. Parallel to this. What is it telling me? The slopes have to be equal. What's the slope of this given equation? All right, so that tells me I want a slope of 2. Yes? And I'm going to put the parallel symbol there, the two parallel lines. So our parallel slope will be 2 as well. We now want it to go through the point negative 2, 3. We have a slope, we have a point. They're telling me I can leave it in that form. So y minus my y coordinate equals slope times x minus my x coordinate. Okay? I probably would clean that up and put that as x plus 2. But that's all I have to do. Okay? It said leave it in point slope form. What do we know if it has to be perpendicular? We said our slope has to be opposite and reciprocal. The problem with this question is, what form did they give me the equation in? It's in standard form. It's hard to find slope when it's in standard form. So we're going to have to do some rearranging. We want to put this in slope-intercept form. So if we have 3x plus 4y equals 8, and I want to solve for y, I'm going to subtract the 3x over. And then I'm going to divide everything by 4. All right. So my original line has a slope of negative 3/4. What is my perpendicular slope going to be? Okay, positive 4/3. All right, so we're going to use that slope and the point 1, negative 5. So y minus a negative 5 would be the same as y plus 5. Our slope is 4/3, x minus our x coordinate. Okay? It says the line y equals 5/9 x plus 6 is graphed on a coordinate plane. A second line is drawn on the same coordinate plane, and it has a slope of negative 9/5 and a y-intercept of negative 6. Write the equation for the second line and describe the relationship between the two graphs. So, what's my equation? I want a slope of negative 9/5 and a y-intercept of 0, negative 6. What would it look like? I'm given slope and intercept. What form am I going to use? Y equals mx plus b. So y equals negative 9/5 x minus 6. Yes? I gave you everything. You just had to plug it in the right spot. Now it's asking what's the relationship between the two lines. The first one was a slope of 5/9. The second one had a slope of negative 9/5. So the lines are perpendicular. All right, our last review question for today. It just asks us to find the x and y intercepts. Now, this equation is not really in any of our standard forms, right? It's not in standard form, it's not in slope-intercept, it's not in point-slope. Can we write it in standard form? So think of it as 3x minus 4y equaling 12? Okay, and when they're in standard form like that, the fastest way to graph it is to find your x and y intercepts. So our x-intercept is the value we get when we plug a 0 in for y. If we put a 0 in for y, we end up with 3x equaling 12. So x would have to be 4. So our x-intercept is the point 40. Okay. Our y-intercept is the value for y when x is 0. If we put a 0 in for x, we have the equation negative 4y equals 12. So y is negative 3. All right. I will be passing out your review homework. Should cover the same types of things we just talked about.